I've done a second example with this missing triangle where I don't have a diagram to work off of. So again, you have to start off with some kind of triangle. It doesn't matter what it looks like. I'm going to make this one like this. I'm going to call it GMP. And when I draw the second triangle, it has to be oriented the same way, meaning that if this goes GMP, and the problem says that triangle GMP is similar to WYZ, I have to label it in the exact same order. So I'm going to go W, because G was first, W's first. M was second, Y is second. You have to follow that exact order, and then obviously this would be Z for the last side. Again, how do you label sides to a triangle? We're going to use that little idea again. In other words, if this is vertex G, it would open up to little g. M would open up to little m. P would open up to little p. For the second triangle, W opens up to little w. Y opens up to little y. And Z opens up to little z. And then I go in here and I have to look at the values. For this problem, I threw a bunch of mixed numbers in here because we need to be masters of using our calculator. So this says that G is 3 2/5. 3 2/5. M is 7 1/2. W is 9 1/3. And Z is 4 2/5. 4 2/5. Now I have two values that I need to find, two sides. I need to find little y and little p. It would be a horrible idea to try to set up a ratio that has those two values. So these have to be done independently. You can only solve for one unknown at a time. As I look across here, I see that I have a left, right idea. So I could set up a proportion like that. I can say P is to 3 2/5 as 4 2/5 is to 9 1/3. Now what's nice about this is it's fairly simple to get P all by itself. And this is one of the things I'm starting to push you guys to look for. Instead of multiplying just by the common denominator, on this problem it would be very simple to get that P by itself just by moving the 3 2/5 up to the other side. So I can say P is equal to 4 2/5 times 3 2/5. You see how I'm taking that up as a numerator? Divided by 9 1/3. For this problem, it does say that they want the answer in the exact form. I'm not allowed to have any decimal. So I have to utilize that ABC button. In my calculator, I turn it on here. I say 4 ABC 2 ABC 5 times 3 2/5. Then I use the division button, the operator, divided by 9 1/3. Now I get this crazy answer. And as I've talked about so many times with you guys, it's okay to get these strange answers. You're using the calculator. So this one says 1 2/11 over 350. P is 1 2/11 over 350. Now I have to try to find y. I have to get a proportion that would allow me to find y. In this case, as I look at this, I think I can say base is to right as base is to right. If you can get that variable on top, it's very simple to solve these things. So on this one, I'm going to say y is to 9 1/3 as 7 1/2 is to 3 2/5. Again, I'm just trying to be consistent here. As long as you're consistent, you can't go wrong. I did base is to right as base is to right. And when I set that up, to solve this, to get that variable all by itself, it would be very easy to just multiply both sides by 9 1/3. If I multiply by the 9 1/3, that essentially just takes this up. And so I can say y is equal to 7 1/2 times 9 1/3 divided by 3 2/5. And then we let the calculator do all the work. Again, all I did was multiply by 9 1/3. I brought that up through multiplication. Simple thing to plug into the calculator. So I say 7 1/5 times 9 1/3 divided by 3 2/5. And this time I got an answer of 19 13/17. So y equals 19 13/17. There's our second example of how to solve proportions on triangles, similar figures, where I had to draw the triangle, I draw the figure of the model to work off of, and then I set up my proportions.